Hello, my name is Sean Ortiz. Welcome to my recommendation report presentation on wind and solar energy. So the purpose of this presentation is to compare HOTS versus monocrystalline solar panels. And HOTS are one of the two types of wind turbines, the other being VOTS, which is vertical axis, and monocrystalline is one of the three types of solar panels, the main types. The others being polycrystalline and thin film. And both of these are the more effective or more efficient of the other types in their own categories. And efficiency is essentially how well a device uses the energy it's given as a percentage. But capacity factor is how much power is outputted versus the maximum that can be outputted. And the reason this is important is because of global warming and the harm that non-renewables do to the environment. They acidify the oceans and cause species to become nearly extinct. And some examples of these would be like coal, natural gas, and oil. And because of them, renewables were created and researched and optimized in order to harm the environment less. The two main ones being discussed are wind and solar, and I discussed the types earlier. And some pros and cons would be that wind is very land efficient, produces a lot of power, but they need to be in a place near wind, very strong winds, so that the maximum power can be produced. So location is important. And solar, they need daylight, obviously. So nighttime is a huge disadvantage for them. So a pro would be that they're very cheap and easy to maintain. And the lifetime for each of them, for wind turbines, it's about 20 years. Solar panels is 25 plus. Now scope, there's three criteria: land use, weather conditions and capacity factor, operations maintenance and soft costs. And soft costs are just the costs like for installment and taxes and anything like that. And 12 acres of land will be considered in Houston, Texas over a year. And some exclusions will be things like snow and hurricanes, because they're so rare. And also any cost before installment, like manufacturing. So a 2.4 megawatt wind turbine fits onto 1.5 acres of land with an efficiency of about 35%. And the 1 megawatt solar farm fits on 4 acres with an efficiency of about 20%. And this figure shows some of the different types and their efficiencies, average being around 20, highest being mid-20s. And both of these efficiencies are the average ones. Wind can reach about 50 to 60 if the best technology is used. But on 12 acres, 8 wind turbines can fit to produce 19.2 megawatts, and 3 1 megawatt solar farms fit to produce 3 megawatts. And this table just shows some of the specs and rating for the wind turbines being discussed. I'd also like to mention perovskite cells, because they are a new type of solar cell, which is both efficient and cheap, but they're still being researched in order to be used on a wide scale. And then weather is Houston weather, so no snow, about 7.5 days of rain a month. And night and day really impact the capacity factor for solar energy. And this table shows all of the capacity factors for every type of renewable energy dating back to 2011. And for wind, it's about 35%, which reduces the rating to about 6.8 megawatts. And for solar, it's about 25%, which reduces its rating to 0.747 megawatts. And this table shows some soft costs for the wind turbines. And applying it to our example, we get about $53.8 million, and for operations and maintenance, about $48,000. And this table shows the same, but for solar panels. So, first, rain is also an important factor because it cleans the solar panels, especially if they're on the axis that follows the sun. But if they're not, then tilted is the best option, and it reduces the cost for maintenance. But of course, you still have to go in there and clean it for every single solar panel. So it comes out to be $3.39 million for soft costs, about $42,000 for operations and maintenance. And in summary, all these wind turbines produce about 6.8 megawatts, but at about $53 million for the first year. And this is the first year only because of the soft costs. But without them, it'll just be the $48,000 a year. You said here. And that means that it'll pay itself off much faster because of all the power it's produced in comparison to solar. So there's more power produced, more land efficient, and higher capacity factor and efficiency, both at 35%. And for solar, there's a much lower cost, but there's much lower energy produced because it depends so much on night and day, because the efficiencies are so low. In conclusion, wind should be researched and optimized because it produces so much more power and can pay itself off a lot quicker. And they produce about 6.053 megawatts more than these solar farms in this example. And the cost comes out to be $50 million for the first year, of course. I'd also like to mention perovskite cells. So solar does show some promise because of the recent years that perovskite cells have increased in efficiency so much, and their low cost and high efficiency can be promising even if it's limited by the daytime. And thank you for listening to my presentation. Here are my references.